Welcome back to the workshop. I'm John Fraser, and this is ScrapCraeft. In this video series, I try to create useful tools out of just what I have around me, using historical techniques and technology. Today, I've got something I really think succeeds at that goal. A charcoal furge, capable of all sorts of shenanigans, while being no larger than a coffee mug. This project is actually the result of a few comments I've received on some of my other videos. The first is from responses to my very first ScrapCraeft project, this ancient Egyptian-style furge, a charcoal furge depicted in the ancient tomb of Nebuchadnezzar in Egypt, which instead of a bellows, uses a pipe the user breathes through to get oxygen to the flame and bring the coals to life. Later on, I made this Renaissance-era blowtorch, which also uses a pipe the user breathes through, but is much smaller in scale and works with an oil lamp instead of charcoal. Some commenters wanted to know if the two ideas could be combined and if a small charcoal furge could be aspirated by a small blowpipe. I thought the idea was really interesting, and I had honestly been curious about it myself. I'm going to be making this furge out of clay, a process I've shown before on my channel. First, I collect soil with a high clay content. The clay is purified from sand and silt by dissolving it in water, and then dried and ground into a powder to be rehydrated with some additives I showed in my alchemist clay video. However, to make the clay heat resistant, I added a much larger amount of sand to this clay body than normal. Sand doesn't expand or contract as much as clay does when it is heated, so the more sand your clay has in it, the less likely it will be to crack when heated. This means it has no problem surviving being fired to terracotta in my primeval pit kiln, and should stand up great to being used as a furge. I made the farm very simple, just a terracotta bowl with a large hole in the bottom and a few smaller holes around the sides for airflow. The whole thing sits on a terracotta ring stand to provide space for air to come up from beneath the furge while isolating the work surface from the extreme heat. I'll be honest, I've tried to build micro-furges in the past, and they haven't been super successful. It can be surprisingly hard to keep a fire going within such a small volume. Fire typically has a sort of critical mass. Too small a flame will just peter out, rather than burn continuously. However, my experience with Michael Faraday's lab furnace, which I reconstructed in an earlier video, has taught me a lot about how to work with fire, and to make it go where you want it to, when you want it to. The main feature I'm going to bring to this project from Faraday's furnace is the removable sheet metal chimney. I'm making this chimney out of scrap aluminum roofing that I found in the woods. Faraday's chimney was made of tin, but this aluminum will be a fine substitute for my purposes. Chimneys are for more than just giving smoke a place to go, and the rising column of hot air they create will act like the plunger on a syringe to pull fresh air into the furge from beneath as the hot air moves up the column, creating suction. However, because the chimney guides the energetic hot flames up and out of the furge, where I can't get to them, it makes it less efficient for actually heating things than if there were no chimney at all. This trade-off is fine when starting the furge, before you're actually heating anything, but it becomes a liability when it's time to actually use the furge. So by making the chimney easily removable, we get the best of both worlds. The chimney's pieces are riveted together with short lengths of copper wire. It's a little tricky to rivet the length of the chimney pipe, but I found anything is possible with a long enough anvil horn. Alternatively, this piece could be stapled together, or a pre-made pipe would work as well. It's best to avoid galvanized pipe, however, as the strong heating this thing experiences would liberate zinc oxides from galvanized finishes that could make you sick. Also, it would be totally possible to make this chimney from terracotta as well. Once the whole thing is riveted, the furnace is basically ready to go. All it needs is a small grill to fit across the hole in the bottom of the furge. I made my grill by burring holes in the steel of an old soup can, and then I used a dapping block to give it a rounded shape. This isn't necessary, but I thought it might help with airflow a little. With that, the furge is ready to go. As for fuel, I'm lighting it with wood shavings, and will be using my own charcoal made from black walnut shell that I fired to char, as shown in the ancient furge video. The walnut shells are great for this because they're a convenient size, but are also incredibly dense and make for a very energetic fuel. Using walnut shells like this is a trick I learned from a very clever farmer, who's a friend of mine. I've used many different types of charcoal, and I have to say I keep coming back to these shells as being the best, hottest burning, and longest lasting of the materials I've tried. With my first couple of attempts using this thing, I used the blowpipe from my first blowtorch project. I had to play around a bit with my technique to see what worked best, but eventually I started to figure out what distance the blowpipe had to be held from the flame and how small to make the pieces of charcoal to fuel it. I was immediately surprised by just how much less charcoal this little thing uses compared to my previous verges. Once getting a little practice, I decided to make a blowpipe especially for this verge. It will be just like the one I just used, just a lot longer, so that I can keep my face a safe distance from the verge. I found that it's better the nozzle for this blowpipe have a somewhat wider aperture than the one I have been using for my most recent blowtorch, and that it be held a good distance from the flame. Around an inch or two works best from what I've tried so far. For my first task, I thought I'd try annealing a piece of scrap copper that I want to turn into a crucible for melting low melting point metals or heating other chemical substances. Annealing is a routine task for metalsmiths, both modern and ancient. It's all about taking a metal that has been stressed or made brittle, and heating that metal to relieve that stress. This copper scrap is old and has been hardened with work and age, such that trying to shape it into a crucible without annealing would take a lot of effort and likely cause the metal to fold and crack in places. This process prevents that by bringing the metal to a high enough temperature that its atoms can slip past each other and move into a more uniform lattice that makes the metal soft and malleable, even when fully cooled. Now that it's been annealed, just a few swift whacks firm the crucible. I thought this would be a fitting first test, as it just so happens that the verge in the mural of craftsmen in the tomb of Nibimun is actually depicted as being used to anneal metal in just this way for ancient craftspeople. A few more whacks with a smaller punch firm the spout for pouring molten metal. With my crucible ready, I'd like to start melting metal right away. But first I thought I'd make a small sandcasting frame to receive the molten metal, so I can smelt it into ingots. The sandcasting frame is basically just a tiny sandbox for molten metal to play in, so all it needs is fur walls and a bottom. If you've seen my other videos, then you'll know I like to work with this paulownia wood. It's lightweight and fun to work with, in my opinion, and it's also one of the fastest growing trees on Earth, and is abundantly available as an invasive species in these forests. The piece I'm using here was just hewn from a firewood-sized hunk of the stuff. I loved the grain on this wood, and decided to give the sides of the frame a light stain with walnut tannins. This stain is easy to extract from the fleshy fruit that surrounds a walnut, and I always make sure to collect some of the fruit when I go around looking for shells to turn into charcoal. I decided not to stain the bottom plate, as I sort of liked the two-tone look. Ultimately though, the finish won't really matter all that much, and you'll see why in a moment. The frame is finished off with some small copper pegs to keep the tenon joints in place. To fill my sandcasting frame, I decided to use some of my clay powder in place of sand. This worked fine for my purposes, but did coat the frame in a layer of orange dust. The first metal I want to try to smelt is zinc. I have an interesting chemistry-themed project in the works that calls for some custom pieces made in zinc, so I thought it would be good to make sure I can work with it. This is the first time I tried melting something in this forge, and I quickly found I put in way more walnuts than necessary for this job. Really, just a few scraps of charcoal would be enough to do small tasks like this, and I think that's really what makes this project special. I got this zinc from some pennies that had their superficial copper coating stripped away. In total, this is just 2 pennies worth of zinc, and I was honestly surprised by how much there was in just 2. Probably more than I'll need. I wanted a crisper ingot shape though, so I hammered it out on the anvil just a bit. Admittedly, I found the zinc to be a little slippery. At this point, I thought I was really starting to get the hang of this little fella, and I wanted to see what else it could do. I want glassworking solder and don't have any of the right gauge, so while I'm smelting metals, I figured I'd try alloying my own 60/30 solder with 6 grams of tin and 4 grams of lead. The metals melted together rapidly. It's really pretty amazing to me to think all this energy can be locked up inside of a walnut, just waiting for the right circumstances to be unleashed on our world with all the fury of a tiny volcano. Solder is much softer than zinc, and I found it pretty easy to smack into a long ingot on the anvil. But I wanted an actual length of soldering wire, so I passed it through my rolling mill a few times, till it was the thickness I was looking for. Metal's ability to be drawn out this way, almost like taffy, will never not seem like magic to me. They always seem like they exist at some point between a liquid and a solid, and the soft solder seems like it's just hardly solid. Similar to butter that's been left out on the counter. It's just asking to melt. I quickly spooled up the 10 grams of solder, and at this point, I'm really feeling like the forge has paid for itself, which admittedly is pretty easy to do, as it's literally made out of dirt, and I didn't spend a cent on it. Well, except for those pennies I melted, but I don't know if that counts. For one final test before I close out this video, I wanted to see how the forge handles iron. Iron is an especially good test because the color a hot hunk of iron glows corresponds pretty faithfully to the temperature it's at. So I should be able to get an idea of the temperatures I'm reaching with this setup just by looking at the hot metal. Ideally, I'd like to get the metal to glow yellow, which would show up from around 900 to 1000 degrees Celsius. So far, I just managed to reach an orange glow, which is just beneath that margin at around 800 to 900 degrees Celsius. This means the forge shouldn't have any problem melting aluminum and could probably handle melting a small amount of various copper alloys if it was pushed to. All in all, I'm really pleased with this little tool. To me, the best part is what it can do with just the tiny scraps of charcoal that a larger forge would just drop out the ash pit. It's easy and a lot of fun to use, and you'll probably be seeing a lot more of it in my videos going forward. I think this thing might honestly be my favorite tool yet. Thanks for watching. If you enjoyed this video, please subscribe. I wouldn't have thought to make this without your suggestions and comments, so please feel free to share your thoughts below. Thanks, and bye!